Well, thank you for joining me today. I want to start with AI21 Labs, the company you helped to found in 2017, which Walden Catalyst recently invested in. Your focus is using language models and natural language processing to improve the way we read and write with the help of machines. Can you talk about how AI21 Labs came about and how your technology is reinventing the way we write and read today?
First of all, thanks very much for inviting me. It's really a pleasure. Yes, the company was started on I think what is a strange premise for starting companies, based on a graph, a chart that looks at the history and progress of AI. If you look back in the 80s, AI was, people, often don't realize it because they're young, not old like me, but AI was very popular, not unlike today, standing room only in conferences and so on. And then you weren't allowed to admit you were doing AI, even if you were in the 1990s. We called it the AI winter. And now, of course, everybody, my plumber, is doing AI, but it's a very different kind of AI. Back in the 80s, the paradigmatic example were an expert system where you go and interview a doctor and you ask her, so how do you diagnose a patient? And she says, well, I look at these symptoms and I ask these questions and I do these tests, and depending on what comes back, I'll maybe do more, some kind of decision tree and maybe a probabilistic framework overlaying it. Machine learning was there always, but didn't really play an important role. There wasn't much data, there wasn't much compute, nor did you need. Today, of course, the story is the exact opposite. It's all about statistics. The amount of data and compute is staggering. And we do pattern detection, pattern recognition at scales we couldn't imagine. We don't do the same kind of reasoning we did back in the 80s. And it's working well. That's the annoying thing. We saw it in vision, where object recognition was really just, I won't say solved, but radically transformed. And in the last 5 years, we've seen it in language with so-called large language models, which is really not a good term, because these huge systems don't just model language, they model information as expressed by knowledge, as expressed by language, or sometimes called foundational models. And suddenly with some of these models, in particular architecture called the transformer architecture, suddenly in natural language, you started to see the needle move. A lot of the academic benchmarks suddenly were dominated by these new sorts of models. But for all the success, and this was the premise for the company, we felt like we've moved to the next plateau, but we're going to plateau because these systems are amazing statistical machines, but they don't understand anything. And take, for example, one of the leading models today that is very famous, GPT-3 out of OpenAI, or others like our own Jurassic 1 model. It's amazing that these systems can do arithmetic. They will do addition perfectly well if you want to add 1 or 2 digit numbers. But give it a 4-digit number addition, they don't have a clue. Because what they did, was memorize what they've looked at in the training data and do some amount of generalization. But we didn't learn arithmetic by just being given lots of examples. We were taught the underlying principles. Those models weren't. And this sort of reasoning is exactly what AI did back in the 80s. We started the company with the vision of merging the two. We felt really AI left a lot of money on the table when we pivoted to deep learning. It's time to merge the two. That's why we started the company.
Mm-hmm. So not just recognizing certain patterns and memorization, but being able to give a better insight. So we're going to talk more about this subject, but let me just also comment on your background. Looks like you're in Tel Aviv with a nice background there. How are things going over there?
Well, the weather is nice. It's a little chilly today. I had to wear my sweatshirt. But the weather is nice, the food is good, the beach is nice. COVID is putting a little damper on things, but not as bad as in other parts of the world. So we're feeling thankful.
Yeah, you're lucky to have a warm ocean nearby, and the COVID-19 seems to be somewhat under control over there. So that's really great. So let's talk a little bit about your first product that you launched called Wordtune last year. It's an AI-based writing assistant that actually I've been using it now for my compositions as well, and it really does give me multiple options. And I know it's not same as Grammarly, but a lot of users may understand Grammarly. So I want to just give you your view of how that's different than Grammarly and in the context of technology and products.
With your permission, I'll start at 20,000 feet, and then I'll go back to the ground level, which you asked about.
That would be great.
So we're an odd company. We're in one part where we like to think that we're a leading R&D lab in AI natural language. But in another hat, we're a product company. We'll talk about that. And we're also a platform for developers. We released AI21 Studio as a platform for developers. So it's a complicated setting. When we thought about our mission for our product, both our own and the one that the developers would be using, we asked, what is the mission we're after? And our mission is to reinvent how we read and how we write. And what I mean by that is that only somewhat tongue-in-cheek, I say that the way we write today is the way a product manager at Microsoft decided in 1980. And the way we read today is the way Gutenberg decided in 1440 when he invented the printing press. Somebody put it on a piece of paper and we look at it. We think both experiences can be radically rethought. And when I say radically, I don't mean doing, autocomplete or better spell checking, which are very useful functions, but they don't fundamentally change the process. We think that if you take AI and make it a basic building block, the machine becomes a partner in these two activities of reading and writing, and just changes the experience. So now let me answer your question. So there's no question that spell checking and grammar correction are a very useful functionality. They're somewhat commoditized by now. They're built in to different degrees and in different ways to both the Microsoft offering and the Google offering. But you do have companies like Grammarly, which are doing very well, and they executed, I think, on that very, very well. Somewhat commoditized. Our tool is different. By the way, as a side effect, we also do spell checking and grammar correction, which, at least in our own kind of evaluation tests, does better than the alternative because it's contextual. If you tell it, I went to the store tomorrow, you'll realize that I went and tomorrow are misaligned, and they need to fix it. But that aside, that's really just a small. We view this as table stakes. The basic functionality is to help you not just write better, but explore your thoughts and then express them. What I mean by that is our thoughts are so high dimensional and nuanced, and the chance that from this very complicated thought, what we output is a very poor sequence of letters. The chance that the sequence of letters will capture what we have in mind is essentially zero. We wanted that sequence to be much closer to what you had in mind. And so there are various functionalities, but the core functionality is a rewrite or rephrase functionality where you take parts of a sentence or a whole paragraph, and the system will say, here are the other ways of saying things. Not because it's a synonym, you change a word with its synonym, but you might say, it was really nice seeing you last night at the party. And the system might say, it was love at first sight. there's no way this is a paraphrase, but it's semantically related, and maybe this is actually what you had in mind. And so this is how the system works, and the experience is really magical. As a side effect, you also get perfect English, but that's as a side effect. And the adoption of it has been very gratifying. So that's the word. That's the writing part. That's Wordtune writes.
Yeah, no, as a user, and of course, I'm also biased since I'm a board member of AI21. But I just love the contextually that I can see multiple options. And sometimes, I didn't really mean that way, but actually that sounds much better. So I'm actually changing the way I thought I was going to express into some other approach, which is much different than just changing grammars or spell checkers. So I do appreciate that, and I hope other users can have time to try. Now, if you are just a new user, how would try the Wordtune? You may want to explain the steps that you can just take.
The best advice I can give is go to wordtune.com, and it's really a fairly seamless explanation and onboarding. But essentially, you have two ways to consume it now: as a Chrome extension or Chromium, so it'll work on Edge also, or as a standalone editor, and there'll be other ways to consume it soon. And then you start writing, and the system will, in a very intuitive, we feel way, help you re-express your thoughts in a way that perhaps are more adequate.
That's great. So now you also launched another product, Wordtune Read, which is another AI-based tool designed to summarize documents so the users can get their content information much faster than reading the whole thing. I wish I had that product when I was going to school, because it would save a lot of time for me. So tell us more about that product and what was the idea behind it?
So, right, we launched this only about a month ago, I think. Because from the start, we have a long-term product vision of rethinking, reading, and writing. And of course, those two activities are intertwined, because unless we're reading the paper or War and Peace just for our own enjoyment, we usually read with the intent of doing something with it, and the something often is writing. And certainly when we write something, we almost always want somebody to read it. So Wordtune Classic, launched about a year ago, was purely on the writing side. So we complemented now with a reading solution. They're both a small part of what we'll be bringing to the market, but already we feel are quite transformative. The way Wordtune Read works is you upload a document. It could be a long PDF document or a web document. And rather than try to give you a TLDR of the whole thing, summarized in one paragraph, which really isn't that useful, or at least the utility is limited. What we do is you get the document, and alongside it, you have summary snippets that you can scan very, very quickly. And the reason you can do it quickly, A, they're much shorter. They can be about 20 or 25%, I think 20% usually on average, of the original length. But even more dramatically, they tend to be simpler to read, simpler language, and they sidestep some of the more complicated jargon, and you get the gist. And so in experiments we ran, experiments we ourselves ran, you could easily get a 10x speed up in the way you read the document. And in an outside sort of agency that I'd afraid who they are, that did experiments, they showed a 75% saving. And of course, you can always go and read the original. So if you look at the summary snippet and it seems relevant, we'll show you where the origin is, and you can go and deep dive there.
Mm-hmm. So if I want to read a New York Times article, which I usually enjoy to do Sunday mornings, I could save some time by scanning some of those documents and then see what the snippet would tells me. And then if I'm interested, I also can go back and to see where they came from.
And I'm sure Tom Friedman would be hugely appreciative.
So let's talk a little bit about the other topics that are pretty typical topics regarding, anytime we read or write, there is this question of bias, AI bias. And there's a lot of concerns about also language models that has the certain radical text or toxic content that could come out. And how do you make sure that we create this bias, AI bias, that could be trained in a certain way, make sure that it does not have the the consequences that due to those content that are coming from?
A very important topic. So, right, whether it's toxicity or bias or issues of privacy, private information leaking, or other potential societal kind of harms, it's something we need to take very seriously. Listen, it's true with every technology. Every technology can be used for good or bad. So I don't think current technology is different in this regard, but it doesn't mean that we don't need to think about it. And we do. First of all, there are various layers in which you do it. Already at training time, you want to make sure that to augment the data where it's inherently biased, to compensate for that bias. You want to clean the data from bad data, and bad can be in various different senses. And so we do that. Then there is at inference time. So when you train a model, you essentially created a statistical model, and then you sample from the model. And when you sample from the model, there too, you can start injecting checks and balances, which we do. Some of them are handcrafted rules, and some of them are trained models using machine learning to detect when something is toxic or biased. We have to admit that this is new, a new frontier. Even defining what is bias or toxic is not a trivial thing. But we're doing our best. We actually have a team dedicated purely to this. But the most important thing I would say is language models are a tool. And when you actually use the tool, it's your responsibility. You bought a car, you bought a Tesla. You can go from 0 to 60 in 3.8 seconds or whatever. You could do a lot of damage. You need to drive carefully. So certainly when we build our own products, we pay a lot of attention to that. And I'm glad to say that so far we haven't had any incident. If we do, we'll jump right on it. And the developers that are using our model are expected to do exactly the same thing.
Now, let's talk a little bit about that, your developer model. Clearly, you're creating this huge training language models and deploying them into production generally requires expensive computational resources and sophisticated AI teams to do it, which you have. And because of that, I think AI Labs now offering as a platform to other partners, publishers, students, artists, researchers, and helping them to build language-based applications. So tell us about what your plan is there and how do you expect your application will evolve over your platform?
It wasn't a trivial decision for us to offer this platform. We're a small company. Even now, we're barely 80 people. When we launched the platform, I think we were closer to 50 3 months ago. And that's a lot for one company to do, right? To develop new technology, to deploy its own applications, and to provide a platform. But we felt it was the right thing to do, and for a few reasons. First of all, I don't want to sound boastful, but the team we have, I've never seen a team this talented, so we just had the confidence that they could pull it off. The second thing is that if we think about our mission to redefine how we read and write, So we hope that every man, woman, and child on earth uses Wordtune and Wordtune Read. And as we unleash new applications, those also. But we're not so conceited that we think that we are the only ones that will ever build applications for people to read and write. And so if we want to further our mission, we should enable those third parties to create the best applications they can. So that's one reason. And the other reason, frankly, is just economic efficiency. Like you said, it's not easy to develop these models. And Jurassic 1, which is the only model we've offered so far, is in a sense a boring model. It's an improvement over, let's say, GPT-3, but it's not a radical redefinition. But it already is a rare breed of, really GPT-3 and Jurassic 1 are the only, 100+ billion, in our case, 178 billion parameter model available to developers. And so it just seems economically inefficient to not make it available. And certainly as we look at our future model to make those. And it's, those efforts for us are synergistic because we eat our own dog food, but our developers are using the platform, and that teaches us a lot of things that we didn't learn ourselves about the model. We learned from working with our partners. And it's working very well. The demand has been staggering. It's an interesting ride. Yeah.
Yeah. Well, I think that not many people can afford 178 billion parameter language models. So I can imagine that many of them want to just tap into your capabilities as a platform to build their applications that can improve their, customer support, chat box, and things like that, that are based on language-driven applications. Can you talk about the scalability? In other words, what is large model? And 178 billion parameters, it's huge, right? It is a huge compute, a lot of memory resource, which, companies like, Samsung will love to sell more memories, and the CPU companies will love to sell more, NVIDIA will be love to sell more platforms. So the question, I think, is what are the trade-off eventually regarding the models that you have to build that are sustainable and scalable?
We've always believed, and I think we believe even more strongly, that size matters. It's an essential component, necessary but not sufficient. So if you just imagine going from current 200 billion to 10 trillion parameter model, which is certainly something in the not too distant future. If you think of going from, let's say, 30 billion tokens, the units of text that are being trained on, to 10 trillion tokens of text and images and everything, there's no question that the model will be more capable, more robust, more capable. And I guarantee you, and you did longer training, and we, in a sense, forcing the models to do more and more abstractions, even though they already know the answer, you force them to encode things more efficiently and to do more abstractions as a result. I guarantee you that even if you did that, the resulting models, if you asked it to do arithmetic, won't stand up to an HP calculator, a calculator from 1960. And so we believe that size matters a lot, but you have to build reasoning into the models. And so we don't think that NLP is going to be a cheap endeavor, but we do think that the brain versus brawn trade-off is going to change, and more brain will be called for. And already now you're beginning to see various interesting works that show that if you just think a little bit, you can get the performance of a GPT-3, which has 170 billion parameters, if I remember right, with something that has, 1/5 of that, just with a different architecture. And so so you start being much more kind of nuanced about your architecture. And the other thing I'll say is, and that's really important, these large models are really important, but it doesn't mean that when you go to production, you need to call them all the time. They're really good at generating training data and basically they use for self-supervision. But then when you actually have your models, you can be much, much more compact. And so, for example, in our platform, the AI21 Studio, we have two models, the jumbo with 178 billion parameters, and we have the large, which is a tiny model of 7.5 billion parameters. It's funny, we think of that as small these days. And we strongly encourage, we almost force the developers to use the jumbo to generate the data, and then with that to create custom models that are large, that is smaller than the jumbo. And the result is, number one, they're much better suited to the application they have in mind. Second, they're much cheaper to serve, and it's a win-win for them and for us. And they're also, since they're small, the latency is so much lower. And so we think that you have to be nuanced with how you build your large models and when and how you deploy them.
Well, just like any other, this race for the more slow-driven, the compute, network, storage, and then of course algorithms, all those things need to optimize, and clearly this will continuing in the pace, which is good for opportunity for tech people like us, because it brings new innovation, and new innovation brings the new capabilities. Clearly where you're going, I think we probably have some ways to go, but I'd love to hear your view of how do language models compare today to what human intelligence is possible, capable of, and what is the next big thing, the AI behind transformers? I know it's kind of a lot of questions in one bang.
There's a saying in Hebrew that that prophecy was given to the fools. So let me offer prophecies then. Listen, there's so much going on. The advances are not going to be along one axis. I don't need to tell you about the new chips and systems of chips coming out that are AI oriented. You know, you're the master of it. That's going to be a driver. I don't need to tell you about how early on we are in the adoption cycle of AI in any industry you imagine. And so those are going to be big drivers. From my more limited perspective, I think that you're going to see, if I look maybe 2 years down the road, beyond that is, I think, a fool's errand, but 2 years down the road, and I look at the advances we'll see, I think that 30% will come from scale. And scale, I mean faster chips, cheaper compute, net GPU, more data, you name it, more types of data, training multimodal systems with language and images and voice and all of that. That I think will be 30% of the advance. I think 70% of the advance will be really rethinking the paradigm and realizing that brute force statistics need to be complemented with a little more nuance. And our horse in the race is this area called Neuro-Symbolic sort of approaches where you combine reasoning with neural. I think there's no question in my mind the next 2 years that's going to explode. Then maybe I'm sure there'll be other advances that I can't think of.
Neuro-Symbolic, something I'm going to watch. So let me ask you one more question in terms of the AI application perspective. People have been talking about biology as a opportunity for AI language model could have applied to understand our genetic sequence or protein sequences or discover new drugs or prevent new diseases. How do you see that application as something that could be an interesting way to really have a big impact on our lives?
So there's no question in my mind that the impact in biology and medicine is already now and will be even greater.
Mm-hmm.
And I say this as a Luddite. I don't work in biology or in medicine, but some of my friends do. And these are all languages. It's the language of the body, the language of our DNA, our RNA, even at the level of system biology. There are rules and there are patterns and there are processes that can be modeled and predicted and intervened with. We saw it in a small scale, not in medicine so far, but people using our models to either generate or analyze code. That's not a natural language, but it's a language. And so, yes, there's no question in my mind, just like in software verification, the techniques, the satisfiability-based techniques to verify whether this compiler is working or not, mm-hmm. have been used in biology very effectively to mm-hmm. see if a certain, to analyze various processes, biological processes. I think the same will happen with language models in biology and medicine.
In some ways, like maybe I can also even use where I am at Cadence, which I'm board member of. Cadence really changed the way you build semiconductors 30 some years ago by being able to build the model and then being able to simulate them and then being able to verify and validate the fact is. And so today, you don't actually do the transistors step by step. You design and then you release those softwares, and then through simulations, which I'm sure has a lot of AI also built in because of learning. And then when it comes out, 100 billion transistor-based chips are working. And that's all because we learned how to model and understand the language of building chips.
Well, if I know little about biology, I know even less about chips, but I've no doubt that what you said is true.
And yeah, it is very interesting how we can apply, because I never thought that that way. But the more I'm talking to biologists lately, I'm realizing we are all in the same way of applying the physics and biology with the way we've been thinking. So that's one way we can solve these problems, I guess, and opportunities.
I honestly think, what was the phrase that my friend Andrew Ng used to, he says, AI is the new electricity. It sounds cheesy. It sounds cheesy, so no offense, Andrew. But I think it is true that aspects of AI now are so generically applicable that there's really no industry or really endeavor in life that won't be impacted. My sister is a professor of literature and folklore, as far removed as from technology as you could imagine. And I find myself speaking to her, she's looking at ancient texts and wants to identify historical development in the text. She has to use machine learning for that. So I think every area in life.
That's really fascinating. Let's go change a little bit to your academic background. You're chairman and co-founder of this academic coding platform in Israel called WeCode, designed to find and train software developers from underprivileged and diverse background. Can you talk a little bit about what's your involvement there?
Yeah, it's funny. WeCode is it's a hybrid model. It's academic vocational. The goal of the goal of WeCode was to lessen the gap between the people with access to technology jobs and particular programming and not. But the opportunity is there's a big inefficiency in the market that we saw, because the standard way, the way I got into the business and you did, we went to college and then maybe we got an advanced degree, so that's 4 years, and maybe we got an advanced degree, and then we went and worked at at Samsung or Cadence or Google. But the truth is, to become a junior software developer, you don't need 4 years of education. Of course, our education at university is not solely for vocational purposes. It's multifaceted. But if you only focus on the goal of securing a good job in high tech, you don't need 4 years. And so we asked ourselves, what can we do that's less than that, that would allow people under young adults, maybe 20 to 30, young, already old enough to be settled and serious, but not already saddled with too many things. What would allow them to enter the profession, be productive, but not create a glass ceiling. So all they could do is go into a highly specialized kind of framework and move things here or there, but that's it. So what we realized that there's an opportunity to create a more compact program that starts with an academic component. There's initially we were 3, then 2 courses, very rigorous, which you did at the university, but with a lot more hand-holding and social support and soft skills. I gave them a lecture on time management, for example. And when that's done, and that's about, I want to say 3 months or so, maybe 2.5 months, then you continue with something that's much more vocational in nature, a more boot campy. We focus mostly on full stack, although some people went to embedded systems. And that longer, that takes, again, that changed because we optimized over time, but started with about 5.5 months. So it's all of 8-month program, very demanding, morning to night. But the end of it, and that was two kickers. The main benefit is we find you a job. We can't guarantee it, but also our model was such that you don't pay anything. But when we place you, that's when we get the money to fund the next cohort. And so, number one, immediate employment. And secondly, the academic part that you took will carry credit if and when you want to continue and to complete a degree. So that was the model, fairly innovative. And we've had, I think, 3 cohorts. The last one's in the middle of COVID, which was very challenging and interesting. They all were very successful. We imagined that completion rates on the order of 50% would be a success. We had completion rates of essentially 100% or 95%, and placement of about 90%. So on that, in that respect, it was very successful. The question is how to scale it. There we made a decision to fold it into the operation of one of the universities here called the Interdisciplinary Center, a very interesting kind of forward-thinking private university, where they have a for-profit operation for continuing education or complementary education, but folding the social mission into that. So that's actually happening as we speak.
That's great. I know it's just good to see that you're working on the not only building great companies, but also helping society with the underprivileged folks. I have one other comments. Clearly, you're a professor, also professor emeritus at Stanford University, as well as you're founder of several AI companies people may not know. After researching a little bit, the trading dynamics, which is acquired by Ariba, Katango, and Timeful, which is both acquired by Google, Figure 8, which is acquired by Care.com. So you have a prolific entrepreneurship and academic background. What are some of your lessons you learned for other aspiring wannabes?
Funny coming from you, right, with your accomplishments. But my usual advice is don't do what I did. No, honestly, I think everybody has their own path and their own way. We all have our own strengths and weaknesses. and we need to understand them and play to our strength. And I've always been curiosity driven. And so when I did my research at the university, I didn't ask, so what would make me the #1 in this area so I can win the most prizes? I asked, what interests me now? What's fun? And what am I enjoying? And the same what happened with the companies. I didn't start out and with the idea that I'm the next Elon Musk. For one reason, when I started out, he was, I think, 5 years old or something. But or Steve Jobs. But it was just so fun to create. And so that's my method is to, and the other thing is find people who are smart and really fun to work with. That's been true throughout my life. And and my current rule of thumb is find somebody who's half your age and twice your brains. And the good news, it gets easier every year.
I concur with you on that for sure. I think it is true though, focus on your strengths rather than trying to become perfect in everything is, I think, absolutely right message. And then focus on the people that can be smarter than you and someone, but at the same time you can enjoy with, right? I think those are the things that makes life interesting.
That's true for me.
Yeah, excellent. Well, thanks a lot. I'm looking forward to another talk, but I really appreciate you joining Next Wave Speaker Series today and wish you all the success. Well, I need to say the same thing because we are together in this AI21 Lab journey. So looking forward to our journey together.
Very much. We really appreciate your willing to join us and look forward to what I think will be a very fun ride.
Absolutely.